Alright, we want to look at another Newton's law problem, an example of using Newton's second law. This time, what we'll do is we'll have a box, 10 kilograms, and we'll assume that we're pushing a box on a frictionless surface, except we have the ability to maintain friction, but our box doesn't. We're going to apply some force of push to the box. So we're just going to come up and kind of push the box. And then the box is going to go into motion. We push on the box for 1 second. And after we've pushed on the box, the velocity of the box is 10 meters per second after push. And what we want to know is what's the force on our box. We can use our equations of motion to get the acceleration, to get the force on the box. So this is a multi-step problem, which is usually what we see with Newton's law. So we study our object's motion. So we say initially x0, x initial is equal to 0, t initial is 0. Then after we made our 1 second push, so now we have t final equals 1 second. Oh, v initial is equal to 0. V final is equal to 10 meters per second. We don't know x final, and we don't know a. Now, we really don't need x final, but we do need a. Because we remember that the F net is equal to m over m equals a. We can find our acceleration from the fact that v final is equal to v initial plus a delta t. Where v final is our 10, v initial is 0. We have an acceleration, and t final is 1 minus t initial is 0. So we see that our acceleration is 10 meters per second squared. Now that we have our A, we can calculate our force, because our force is just the mass times the acceleration. So in this case, we have 10 kilograms times our acceleration of 10 meters per second squared. So the force of our push, which is the only force on the object, must have been 100 newtons, because we have kilograms times meters per second squared, which is the unit of the newton. And so this is another example of a second law problem, where this time we were given information about our object's motion. There was a box sitting still. We came and pushed it for 1 second. After the push, we noticed that the box was moving at 10 meters per second. So we use our equations of motion to get the acceleration. Once we had the acceleration, we knew the mass, we were able to get the force of the push.